Welcome to the FarmBits podcast, a product of Nebraska Extension Digital Agriculture. I'm Jackson Stansel.
And I'm Samantha Teaton, and we come to you each week to discuss the trends, the realities, and the value of digital agriculture.
Through interviews and panels with experts, producers, and innovators from all sectors of digital technology, we hope that you step away from each episode with new practical knowledge of digital agriculture technology.
Welcome back to the FarmBits podcast. We are continuing to roll through our planting technology series, and I'm very excited about this episode.
Planting equipment continues to advance significantly in the modern ag tech landscape. This episode features a company at the forefront of planting technology innovation.
Paul Harms, Product Support Manager at Precision Planting, joins this episode of the FarmBits podcast to discuss Precision Planting's mission, product platform, and vision for future innovation.
We dive into many topics from data to sensors to equipment and how Precision Planting is doing exactly what their name suggests, enabling precise planting operations.
So here's our interview with Paul Harms.
Paul, it's great to have you here on the FarmBits podcast. And I guess to get us started, would you tell us a little bit more about yourself and kind of what your role is at Precision Planting?
Yeah, I'm super excited to be here. I appreciate you guys reaching out and getting the invite in. My name is Paul Harms, in case you haven't seen that or read that yet, but I started with Precision Planting about 13 years ago, and I work in the product support department. So I grew up on a farm. We had 2,500 acres of row crop and then 300 head sow operation, which we did farrow to feeder and farrow to finish. So came from the farm background, spent some time in the seed industry, kind of got in the door here on a whim, just on a flyer, and have loved the role, the task, the people, the culture, and the mission. So that's been a blast that I just can't walk away from.
Awesome. And where are you from originally?
I grew up in central Illinois, right here, about an hour or two north of here.
Awesome. Must be close to home.
Yeah. And I'm located right at the home facility here in Tremont, Illinois.
Good deal.
So since you brought up the mission of Precision Planting, can you talk a little bit about the company and what kind of role they are fulfilling within the industry?
Absolutely. I would say our mission is very similar to the title of our podcast, the Smarter Every Season podcast. Our goal is to help growers improve year over year. And we feel it's our role to try and provide education opportunities and solutions to problems that they're seeing. We do that through our Precision Technology Institute, our winter conferences, our field demonstrations. We provide our solutions in a retrofit fashion and our factory installed through our partnerships there. And it's all about taking advantage of every time we go to put a crop in, trying to put the best crop in and make our operations as secure as possible.
That's really cool stuff. And I think the retrofit aspect of things is a really important asset for farmers. And from an engineering standpoint, I just think it's a really important way to design things. Can you tell us a little bit about some of the great lineup of technologies that y'all have, including some of those retrofit pieces of equipment that you offer to people?
Yeah, the retrofit is actually our bread and butter. So we approach problems that we find in the industry first and foremost towards that retrofit solution. We want to make whatever problems we can solve with a product or a design. We want to make sure that that's applicable to as many people as possible. And there's a much larger portion of the industry has an existing implement in their shed than there is new going out every year. So we don't want to just make it tied to that new. It's important for us to be able to continue to add value to that existing implement. Our start with that was the Keaton seed firmer, which was just an attachment onto a row unit to help firm the seed down in the soil. And that's our focus there, is finding those solutions.
Awesome. So it's really interesting that, kind of you're talking about the seed firmer, but those seed firmers have kind of morphed themselves, or not necessarily morphed themselves, but you've expanded from that point to doing a whole lot of more high-tech ththings than just firming seed into the ground. I mean, you got different V meters that you put out for literally different specialized applications. You've got different, you have your smart firmers out there, FlowSense, FurrowForce. I mean, we could go on and on. I mean, can you tell us a little bit more about some of the technological advancements that have happened from those regular seed firmers?
Yeah. So a lot of that does track along the same path where when we started, we were focused just about helping that seed with emergence and ensuring it gets good, solid seed soil contact. And that was adding a firmer onto the back of the row unit, made sure that the seed was placed fully into seed contact. And then that has grown into, well, I made sure all the seeds were starting and emerging correctly. Why do I still have an erratic stand? Okay, so then we start looking at the meter. What's the next problem? And a lot of times it's just continuing to advance and look into what are those next problems, and then understanding how they occur, finding a good solution that provides value in the operation, and then putting that product out. So, as we worked through all those, a great anecdote is one of those stories where one of the first engineers took his laptop and he was doing some testing, looking at meters, and he was using the existing sensors that were on the planter. And for us, sensors and information drive a lot of where you can improve, because until you can measure something, it's hard to improve on it or advance that against that problem. So he would take his laptop out, plug into the planter, and all of a sudden the operator could see so much more than what the existing technology in the cab offered him. And the engineer would get what he needed and pack his laptop up and go back and do some design work. Well, what the driving piece came out of that was, no, don't go away with that. I can see more. I'm not adding any new sensor. I'm doing more with the data in real time, and I can make better decisions with that in the cab seat while I still have time to impact my yield for this year. And that was one of those light bulb moments for us of, while we were designing towards one thing, and we still continued with that, but it also opened an opportunity of knowledge was a big driver of being able to make the right decisions.
Very
That's
cool.
awesome. Yeah. So thinking about that, collecting data, but more importantly, using that data, can you talk about the smart firmer, which is that reflectance-based sensor for people who may not be familiar with that? But what are some challenges that are associated with this technology, particularly with making sure that data is accurate, but how does it adjust with different conditions and soil types?
Okay, how far in the weeds do you want to get with the that? So if I go too far off the rails, just corral me.
Okay.
For the most part, it's so the smart firmer is a great example where we have gone from a product that solved an immediate solution or an immediate problem. It was a quick solution to a problem of seed to soil contact and uniform emergence. As we progressed along, we got to the point where we wanted that, or we had the desire towards, I just want a window into the furrow to what my seeds are seeing. If I knew that, I could make a better decision. And this is from us as operators and time in the seat, wanting to do better with this season's crop. So we said, well, okay, let's find out what instruments and things we can put on that to give us that window in there. And the smart firmer is the tool that we came out with. What it's doing is it is a reflectance based sensor. So we have some lights in there and they're shining against the soil. The major hurdle is when you get that reflectance back, you have to correlate it to some known. Okay, what does this data mean? Right? The way you figure that out from all the different data is a bunch of backbreaking work in validating it and testing it in a known condition against every possible iteration. So we went from this great idea of I want a window into the soil, I want a visibility into the furrow, to a warehouse portion of the warehouse that's full of 5-gallon buckets of soil from all around the world, as many places as we could. And then not just getting the samples, but then testing them and going, what is it at 0% moisture? 5, 10, 15, 20, 30, 40. What does it look like? What are the reflectance values? And smart firmer is really beautiful in the way that it doesn't just tell me how much moisture is in the soil, because that would be potentially a misinformation. And I'll go into why in just a bit, but it actually is reporting to the user how much moisture a seed can pull out of that soil over the next 3 days, because that's the imbibition period. That's when the seed is going to start sucking that moisture. And we need that to all happen uniformly and enough to initiate the germination process. So we didn't just look at the soil and say, okay, at this amount of reflectance for this type of soil, we're going to get, or this is how much moisture is in the soil. We actually then took it and said, with this soil at this amount of moisture, if nothing changes, will the seed have enough to begin germination in 3 days? And the example and the reason back for that is I can have a sandy soil and it can have 30% moisture in it. Right? Think of it like a gas tank, right? My sand won't hold as much as a clay. I have a smaller gas tank, but on a clay won't give me every bit of water that's in it like a sand will. Sand will give you every ounce of gas that's in the tank. A clay holds on to half of it. So the same 30% moisture on both of them is a different amount on how much my seed can get. So when we put a number on our monitor in the cab, we're constantly driving towards the number that affects seed germination. So we want to stay over a 30%. We want enough moisture to be in this soil type that over the next 3 days, that seed will have enough, be able to pull enough moisture out of the soil to gain 30% of its weight by volume.
Sure. And so is that moisture aspect then kind of the primary value driver for smart farmers right now, at least on the real time side? And then the organic matter is a little bit more of kind of a post-processing side, or I guess, how does that work? Because it does both, right?
Yeah. So there are 6 layers of data that come out of Smart Farmer.
Okay.
And when we launched and announced Smart Farmer, we were super excited about, hey, and we can do organic matter. We initially went into it with the moisture focus, and then halfway through that, we're like, well, we can easily correlate this to organic matter. We're getting that number in our data. We can just start to present that as well. And it was kind of that, wow, we're excited we can also include that. But that took a lot of the notoriety. But there, of those six data layers that we're getting, 3 are extremely valuable to the operator in the cab, year in, year out, acre by acre. 3 of them are great for informing and influencing long-term decisions. So the 6 that we have are furrow moisture. So that's how much moisture is in there. My furrow uniformity and my clean residue, or my furrow residue, what amount of trash is in my furrow. The last ones are temperature, organic matter, and CEC. So those first 3 are the ones that drive best practices and can save this crop from having a skip or a large gap as I wait for seeds to get enough moisture to germinate. So those are the 3 that really help an operator do a better job this year.
Can you elaborate a little bit more on that value proposition when you say it can help make management decisions? So if, let's say, a farmer says, or they get that message that says, oh, it's not enough moisture to last those 3 days, what can they do about that? How is it actually changing their management? Does that make sense?
Yeah. So, and this is a great question that we will commonly have with growers, and they'll ask us at farm shows and things. So what's the value prop on that? Or how do I make a change, or how do I utilize that information? And we'll commonly ask, or at least I'll ask the question back. So what depth do you plant your seed at? And varying number of answers will come back, and it'll depend on crop, and it'll depend on where they're at in the world. When it comes down to it, what does the seed need to begin germination? Temperature, water, a little bit of air, right? So we can really affect mostly moisture. So if we have a measurement of what's in the soil where the seed is, the one of those 3 that we can target, we go after. So if it's dry and we don't have moisture present, well, stop, get out, go back around the planter, set your planter to target a little deeper until you do find moisture. Or even better yet, maybe you can't find moisture and this seed and this field is better saving my yield with that seed in the back.
Yeah.
No matter how bad it is. And sometimes this isn't an equation. If I have a fully irrigated field and I'm going to water the crop in, great. But that can also be a big value indicator of, hey, there was enough soil, or there was enough moisture in that soil. I don't have to water it in. I can save myself one cycle around on that. And that can be a huge impact on how much water you use in a year and just an additional pass cost. So those are some easy, simple ways that inform that operation and gives that operator, the guy in the seat, the right information at the right time. So then some of those we can continue to automate. And in the same way that our seed firmer, our standard poly Keaton seed firmer that has grown into a smart farmer. We added a sensor and gave it some more value to us and some more input. Now we can take smart farmer, and now that we can measure that moisture on the fly, well, the first thing you would react to on chasing moisture would be depth. So now we have a smart depth system that solves a couple mechanical problems and gives us the ability to respond in real time to that moisture value.
Very cool. So because I really want to dig in a little bit more to this real-time response and control, because I think that's really the cool aspect of having all these sensors on a planter. But before we get to that, you talked about precision planting wants to make people smarter every season. So when you think about some of this data that you have coming off the smart farmers, that one helps with real-time management decisions, but then also is additional data that growers can use in other parts of their operation. Does Precision offer any like decision support tools or recommendation tools that help growers to kind of process that data and turn it into something that's actionable for them? Or is that something that you usually rely on growers to do on their own?
So a lot of our focus is on creating the data layer, capturing and doing the high performance job in the field. So we don't have a service or a product where we are guiding or coaching. We would much rather encourage our dealer network, our resellers in the field. A lot of our dealer partnerships, those guys have a local knowledge and experience to really make the most value out of that. And they've got the tools that are available in the industry, and we're always there to back them up, help them, give them guidance and experience. But that's rarely done exceedingly well from a mass aggregated. It's really done successfully that I've seen so far in a partnership relationship where you have a guy across the kitchen table or a lady helping you come to the right decisions. Here's my information. Help me make the right decisions on these acres. So that's what we try to facilitate first and foremost.
Yeah.
So all this data is really valuable if it is accurate, right? And you guys talked about your validation process. You guys are lots of soil types, lots of different moistures. But is there a way for a producer to potentially calibrate this information on their own field? So potentially taking moisture samples, organic matter samples, or anything like that to potentially better inform these data layers?
Yeah, we're kind of riding the smart farmer horse on this one. So as that example, but Smart Farmer is a great example for this reason. Its primary goal in the field is not to create the absolute value of organic matter or any of these values. Our full target is to create the spatial variability, right? So I can then understand how this portion of my field behaves differently than another portion of my field. And I can always correct that legend later. So if I see a variability from 1 to 3, on a field, and that really needs to be from 2 to 4, I can go correct that after the fact. What I'm most focused on is that I'm able to control real time to the variations in the field as it goes from 1 to 3 back and forth across the field. So yeah, all those data points. So specifically on Smart Farmer, you can take your Smart Farmer data and send it up. And we have a server that has a program built on it, and you put in all of your soil samples. And if they have GPS data points, it will correct that map and legend to a corrected value, to that absolute value that a soil sampling test like site would give you.
Yeah, I think that's extremely valuable. I mean, just thinking about dealing in relatives instead of dealing in absolutes, right? Like that's really what we're trying to get to here is like, if you know, I guess, and this is how I would interpret it. If you know that you're planting at the right depth for a certain moisture, right? And you know that all of a sudden your soil's gotten drier, well, you're probably going to have to, increase your depth in order to get there. It doesn't necessarily matter exactly what that moisture is, but if you know that relatively speaking, this part of the field is drier than another part of the field at a certain depth, you still have enough to kind of make that decision. Am I interpreting that the right way, Paul?
Yeah. So going into smart depth for us has a few different ways we can control it. We can just put in a value and say, I want this thing to be planting at 2 inches. It always plants at 2 inches. Straightforward, very simple. We can also put it on a moisture basis, which says, here's my preferred depth. If I fall below this certain amount of moisture, go deeper. If I get too wet, come shallower, right? And you can figure it so, it stays within a window or a range that's right for your acres, for your locale. And then we can control within that to make sure that we're giving the seed the best opportunity, because you don't want to go too deep if you don't have to, because then you're just making it harder for that seed to get through up to the surface and actually see the sunlight. So we want to keep that as short as possible to reduce that resistance. The last way we can control it is off of a prescription. So if I know I have an extremely distinct soil type difference in my field, and I normally would love to plant the left or the south half of my acres on 2 inches and the north half at 2.5, I can do that. I draw a prescription, and then my default depth goes to that, and I can still control the moisture. I'm just affecting my default depth and allowing the system to do what's correct. And now that's changeable or modifiable on the fly, which is really interesting. The engineers were actually able to make it so that that prescription and the controls could be read by the system and controlled to. We can edit, make live edits, make the update, and it's a faultless process, so that it's a read and update at the same time. It's pretty impressive.
That is pretty impressive. This is all like right there in the 2020 system. Just whoever the operator is making changes as they go. Okay.
Yep. As auto steer has allowed us to get a little more relaxed.
Sure.
One or two fewer things to do. Now I can start tweaking my operation, my management, my process on the fly, and we want to encourage that.
Sure. Yeah. Instead of watching FarmBits YouTube videos, you can go in and actually edit your prescription, right?
Maybe they just hit pause while they make an adjustment.
There you go. That's right.
So thinking about how planting conditions are not always optimal, as we would like them to be, can you talk a little bit about maybe some calibration challenges, or with any of these technologies, how are you making planting more stable across multiple soil types, maybe different moisture conditions? What kind of technologies are making that where you're consistently planting how you want to plant at different conditions?
So I would tackle that. I would answer that in a couple different ways. One, I have to first make sure that I'm prepared as possible. So if there's physical or installation pieces, I need to try and set that planter up or equip it with the right amount of tools and pieces to be successful. So do I have the tools in place that I can make my adjustments, or that it will handle it automatically? So that's first and foremost, is make sure I'm configured for the best possible success in all scenarios, or at least the scenarios that I'm going to run into. The next part is those sensors. So we want to be able to know when situations change, when the environment demands something different out of the implement, and be able to respond to that. So commonly, if it's an automated control system, if the soil has just gotten a little tighter, well, maybe the system can just it has a target value, and it will push down until it hits that target. So it kind of overcomes some of that need to calibrate, kind of negates some of that. Probably the biggest part that's still an unknown and that won't go away is the ground truth. The value of ground truthing or data validation is always going to be there, and we can automate a control to any target that the operator wants us to. Right, within our control range, we can do all the automation. We don't know that the control target is 100% perfect. That's left to the grower. We know we need the grower to say, this is where I should be doing for this field. So some of that is still, get down on your hands and knees, maybe say a prayer, and then and evaluate what the equipment is doing to the ground, and making sure that it's accurate for what you're doing.
Sure. So when you think about a product kind of like active downforce, the Delta Force systems that y'all have, I guess that's kind of one of those examples that comes to my mind when I think about, the farmer still needs to kind of set the right down pressure. But I'm also thinking that there has to be some truth out there, right? Of like, this is too much down pressure given these moisture conditions or soil type, right? And then this will lead to compaction. So, I guess, how are y'all going about implementing this Delta Force, and how is it bringing value and potentially helping farmers to make better decisions as far as how much downforce they're applying out there in the field?
That's a multi-headed beast.
Yeah, I ask way too many questions right there. I have a tendency to do that.
But that's a good topic to unpack, because there's a lot to that one. So downforce, I've never given a direct answer of what's the correct answer, what's the correct downforce amount, because even in the field that's right next door that we've seen, and I've been on a dozen years in a row, I don't know its conditions, its moisture, how the winter affected the soil structure. It's going to handle different this year than probably it has in any one of the previous 10.
Yep.
Maybe some similarities, but it's going to be unique. And I need to be able to confirm that I'm setting the right target. The system will go, and I've got some presets. I can affect how I do towards that and simplify my life in setting that target. But I do need to be able to make the correct decision or make the correct target point that the system controls to. And that would be, that's going to be present, pretty straightforward across all of the products or any of the actions we do across the field. We do need to have that ground truth to know that we're doing the right thing with the equipment. With downforce, we don't technically target what the right amount of push down is. We know we need to push the row unit down. We'll continue to do that until we get the correct amount measured on our depth stop. So we just keep pushing down on the row unit until we've hit our target of force against the gauge wheels. And the example, you go in your garden, you guys do any gardening at home?
Just a little bit, yeah.
Okay, so in your garden is probably like my wife helps me make ours. Perfect, super fluffy, nice, no problems, weeds or anything. And so when I go to plant that, it's make a little hole, put the seed in, cover it up, and then what do? You tap it
down. Yep. Yep.
So there's a certain amount of that where you're resetting the soil structure and the density of the soil above the seed. You want it firm enough that it holds air and water correctly, but you don't want it so firm that the seed can't get that germ.
Yeah, absolutely. Yep.
So the gauge wheels on a row unit, on a planter row unit, are, for a good portion of that, your firming action. They have an impact on what your soil structure is around that. Your closing system is like the wax job after a good car wash.
Yeah.
If you don't wash and chamois and wax it, the wax and the chamois can make a wash look really bad.
Yeah.
It's that finishing touch. So all of that resetting, we want to make sure that our push down is as it should be, but that takes the operator to choose that. So we'll push down as hard as you need, anything up to 650 pounds to push down, or we will remove weight for the row unit as much as 450 pounds. And we can make those changes extremely rapidly, probably more rapidly than should be needed in the soil. But the focus is just having the ability to hit that target very accurately, each row behaving independently and hitting its own target, because as this row is going through a tire track and the row next to it is not, they're going to have different demands on what's needed to push that row unit down to get the right measurement on my gauge wheels that says, hey, yes, I've met my depth and I'm doing the right thing to firm the soil around the seed.
Absolutely.
So when you talk about how rapid that is and the amount of measurements it's taking, is that kind of a noisy measurement, if that makes sense? So like we think about it's collecting it so quickly that maybe it's over adjusting, or I don't know if it's too much data or too rapid that it could potentially not be consistent.
So part of that process we talked about earlier of the what's the calibration process, or what's the pain in a system, and how with Smart Firmer, a lot of that pain was in the development process. We had to go through the legwork to understand all of the different soils and all the reflectances before we could give the right education. And we weren't just giving what moisture was in the soil. We were giving what moisture can the seed pull out of the soil, which is that next level. All of our engineers try to target that. I want to make sure I'm not just giving data, throwing data at the user. I want to make sure that the number that's displayed on the monitor in the cab is a number that they can relate to and say, okay, above this is good, below that is bad. And then we put a color code on there. Unless you're red, green, colorblind, it really is, it's like a stoplight. So our whole display is focused red, green, and yellow. So if the entire display is green, keep going, speed up until you start to see something drop in performance, slow down, balance that out. When you do see yellow, slow down, investigate, check out what's going on. If you see red, push the clutch in. Right. So all of them, and each one of the metrics that would flag yellow, green, or red, those metrics are customizable by the end user for their operation. So singulation may not be an issue if I'm doing something like canola. Canola is a pretty high seeding. Singulation is actually still pretty important in canola. So take an example of some of the higher rate 30-inch soybeans, right? Those seeds are extremely close. One seed's distance to another's neighbor's, right?
And you can afford to lose 40, 60,000 to probably still make your yield.
Depends on how you target, right? Yeah. So you can set the metrics or the alerts or the alarms differently for that crop than I would for corn, right? I know I've got a very tight relationship on a yield impact with corn. So about every 1 point of singulation loss on corn, I'm going to see about 1 to 1.5% of my yield potential drop away. And I say percent of yield potential because we take a gentleman or a farmer who's in a 150 bushel yield environment versus somebody who's in a 600 bushel yield environment with the Corn Kings for currently. That 1% is different. And I think it's more of a percent of your yield potential.
Interesting.
Mm-hmm.
There's a different way to think about that. I guess just kind of digging into this data a little bit more, we've brought up singulation, right? And how important that really is. I would imagine as quickly as planters move, relatively speaking, and especially now that we've got high-speed planters coming out and coming on the market, singulation has to be fairly challenging to measure. I mean, how has precision been able to get down to literally, tenths of a percent of singulation and reporting that to farmers as a very valuable metric to them during their planting operations?
Phrase that again.
So I guess how I imagine singulation is pretty challenging to measure, and maybe I'm off base on that. I don't know, but as quickly as seed is moving through kind of a planter, how have y'all improved measurements of singulation versus kind of other planting systems that are out there and all that?
So singulation as a whole is not terribly hard to measure.
Okay.
Just statistically, to be able to differentiate one seed from its neighbor, there's a certain level. Once you get over a certain number of seeds within a second. So a normal corn planter going through the Midwest at standard seeding rates is going to see probably at most 14 seeds per second down each seed tube, right? Most of the common optical seed tube sensors that are out there will have 30, 50, or 80 seeds per second as their top end on what they can accurately measure going through there. So it's just a matter of listening to those pulses and being able to identify and distinguish a singulation versus a spacing error, right? Those knowing what to do with the information, and then once you've got that, presenting that to the operator correctly is the key, the magic sauce there.
Yeah.
The technology actually exists. So even if you take a standard planter and you go twice the speed, 28 is no problem. 30, 40. Once you get over a certain number of seeds per second, like in that soybean conversation we were talking about earlier, there's really no value in distinguishing between a properly singulated and not singulated because mathematically there's no deviation. So there is an upper limit on where you can still continue to provide singulation, but on any of the commonly focused on singulated crops, sugar beets, corn, cotton, their seeding rates well within spec, and we can distinguish those with the bulk of the optical sensors that are across the market.
Sure. Yeah, I just had no idea what exactly the measurement rate was on some of those optical sensors, not coming from a planting background or anything like that. So that's interesting to hear. I don't know. Maybe people don't know that up there. I do.
Yes. This is definitely going down in the weeds, but if you look across the industry, there's two seed tube sensor styles that are commonly able in a non-speed style that are commonly able to read the highest, and they're over 100 seeds per second. but that would require a bench or a lab environment where everything is perfect and uniform and there's no vibration or variation induced by row unit movement.
Sure.
In the field, we commonly see that live at about an 80 seeds per second as the upper threshold,
Okay.
to where seeds can be accurately identified individually between one seed to the next with all the row unit movement and such. That would be both Dickie John's 10i, their high rate plus, and our Wave Vision. When you go to the high speeds, I think both our own speed tube and Deere's Exact Emerge, both of those are able to meet or exceed those.
Very interesting.
Mm-hmm.
And I guess, so kind of getting into this, you kind of brought up the, lab or bench top and how you kind of have to have very fine conditions that you don't have in the field. And we're talking about for optical seed sensing here. But if you think about some of these other measurements that are going on out there as well, we're thinking about how much, down pressure is being applied. We've already talked about the moisture, kind of ad nauseum, but, I'm sure there are other, measurements out there, temperature, whatnot. If any decisions are being made on these from the cab, how important is it to be able to filter that noise and how much of a challenge is that for real-time control, having this really noisy system out there in the field?
So as soon as we were approaching and starting the product design process for a high-speed solution, we knew that every one of our products would then get applied in a high-speed environment and needed to be able to maintain performance and accuracy across there. So like we designed Furrow Force, our closing system. High speed was a prerequisite before that could be a viable solution to solving closing as a problem. So all of that, as soon as we decided, yes, planters can and should be able to cover more acres or cover acres in a more timely fashion. Yeah, all of the pre-work had to be done on the other components. As far as for speed of communication and control, our monitor, the 2020 Seed Sense, has 4 unique CAN networks inside it. So we can parse the implement into smaller portions that we can have an extremely high data packet speed.
Yeah.
And fill it completely with all kinds of devices that will allow us to provide those solutions. So it's not a huge concern for us on being able to carry that data through.
Sure. Yeah. Carrying the data, I'm sure, but I'm sure as the noise has to be something that's pretty significant to deal with. But I'm sure that, on the monitor side and kind of the engineering side, they've obviously done a whole lot of work with being able to filter any bad data or, any of that noise from vibrations or other things out.
Yeah. And again, it comes back to the engineers that get the boots dirty in spring, riding with it, and understand that I don't need to just bring forward the data. I need to bring forward the piece of information that drives the right behavior in the cab by the operator at the right time. So again, Smart Farmer is a great example. I don't want to just bring them how much moisture is in the soil. I want to tell them, for this soil, how much moisture can my seed get out of it?
Right. It's actionable.
Yeah.
I think the one product that we haven't really touched on a lot yet is the Furrow Force. Can you maybe talk about that a little bit, and how is it adjusting in real time to make sure that seed to soil contact is there?
Okay, so pull back a hair. Seed to soil contact is primarily driven by the farmer ahead of time. If we've done our job right, we place the seed in the furrow. Now it may have gotten hung up, or it may be just resting along the bottom of the furrow. What we first want to do is have some farmer press it down securely into the soil, and then I get 100% envelopment by the soil around, except for on the maybe small little top area that I need to then close. That gives me a couple facets. One, I know I get good enclosure all the way around, but I also get a uniform depth. So they're all pressed just under the base of my furrow, right?
Yep.
Where they should be. What we're doing on the closing side is more of tackling the two biggest problems of what the row unit did to get the seed there to begin with. First, it had to carve the soil open.
Mm-hmm.
So I need to first remove that. And then because I carved it open, I messed with the soil structure. I need to reset that. So our closing system, the Furrow Force closing system, is targeting those two actions. First, I need to destroy or undo what my row unit did to create a furrow. And then I need to reset the soil density above the seeds. So it's not an air pocket or it's not a dry space, can hold moisture. And then two, I don't make it so firm or tight that the seed can't sprout through there. So that's what Furrow Force is doing. What we do is we have 3 different versions of our control aspects on there. So one is a manual only. You would just manually fill a pneumatic bag to your desired amount of force pushing down and run with it. The second way would be you would have some sensors on there that would tell you, am I holding my closing system down hard enough? Now, again, this is a control or a target set point that you're going to be choosing which of the right set point is. Yep. But we continue to push down on the closing system as a whole until we meet a measured weight on that stitching wheel on the back. So that's how much I'm firming the soil back together with. We'll continue to push down until we measure that we've attained that amount of force. You set that target rate and we chase it. With that middle layer there, we put the sensors on there. We give you what you're measuring, but you have to manually adjust it to hit that target. The last one is we put an automated control piece on each row, and you tell it a target and it maintains it. So as you go into softer soils, it lets air out, makes it walk across the soil a little lighter. In harder soils, we continue to push down until we measure that right amount.
Sure.
That's interesting.
And the fun part of that is, so the fun part of that is really, I can also do that to solve agronomic problems as well. Maybe I'm in an overly tilled environment. It got wet. I had to till it to get moisture out. Now I've got a little bit of clods, so I hit it again, and now I've got overly fluffy soils. So I can actually add extra pressure on my closing system to maybe firm that soil back up and retain a little bit more moisture than would normally be available. So I can use it as a tool to help me out of bad situations as well.
That's really cool. And I think just thinking about the value proposition for all this, we think about how much farmers would have to get out, or the operator of the planting system would have to get out and go and reset all these things without kind of the automated control, right? It's really going to slow down your planting operation, which we all know has to be timely. And so, I mean, is that the biggest value proposition for some of these tools, is that, really you don't ever have to stop. You can make those adjustments on the fly. Is that what a lot of people are seeing out there as a value?
So there's got to be an agronomic value to it. Standalone. We have to be solving a problem. And that goes back to our entire mission of, we like to make sure that what we're doing is solving a problem, right? Farmers are an amazingly industrious lot. And if there's a problem that they know about, they can solve it and they can do a better job. They have that innate desire. We have that innate desire to do better. And so that's why a lot of our mission is on focusing on encouraging that education and helping people understand where problems come from so they can solve it. So coming back to your question of getting the right setting points in there and stuff, that really falls down to just giving them the right information. Yeah.
And I like what you said, and sorry, Sam, I know I'm kind of cutting you off, but I really like what you said about the agronomic basis for all of these activities and kind of the education piece and getting smarter. I mean, in preparation for this interview, I was kind of on y'all's website and looking at some of these videos, and I was just enthralled, 8-10 minute long videos, however long they were. I was just really enthralled by how much education there really was going into those videos. And it seemed like that really was a point that was being made.
Yeah. Coming back, I don't think I answered your question perfectly. I kind of, my brain froze there. I'm sorry. But so the timing and the operation and the what the impacts are there, our first solution has to be, we actually solve an agronomic problem. The speed or ease that we can do to maintain the optimal performance, that's an added benefit. Speed tube, our high speed planting solution, that's first and foremost goal is to get more acres in the ideal planting window. a side benefit of smart depth is I can make a depth change without having to get out and make those changes manually, right? I have the agronomic benefit of staying in moisture all the time, but I don't have to get out and change. Clean Sweep, our row cleaner control product, all it does is make changing those row cleaners simpler and easier, so I don't have to choose between beating the rain, managing the other activities and operations that are going on my farm, because most often the operator in the cab is not the second or third person on the operation. They're usually the primary person on the operation who has to direct the entire choir of activities and make sure that no horns get out of tune. And a lot of times what will happen is there's not a loss of desire to hit that perfect or to hit the optimal performance. It's a priority choice of I can either continue to strive for performance, or I can keep that problem that's another aspect of my operation from hitting a dead end or stopping completely. And in the larger sense, those priority decisions sometimes have to be made. But if we can give them the tools that allows them to make those changes or create a set point that they're confident in and let the system maintain that performance while they can then do their operation management, that's a great side benefit.
Yeah.
That's good chances is as valuable to the guy in the cab. But the product itself needs to stand on its value.
Yeah. That's a really good answer. I like that.
Yeah. So thinking about this value, I'm going to ask kind of a two-part question. Can you maybe first tell us what is current adoption with some of these technologies? Is these things with planting a huge priority to producers right now? And then the second part is, what are producers most excited about? Where do you guys think this adoption is going?
I don't have hard numbers on what current adoption is. So as an anecdotal answer, when I started 10 years ago, 13 years ago, whatever, a lot of the conversations I would have, say downforce is a great example, were explaining how a setup or a miscalibrated system would give you an agronomic cost. It was very heavy on the education of where a problem existed and how to solve that. That was truly a cost to their business. Then once when we understood where that fault could come, it became more of a, how do I select the right tool? How do I operate the tool the best? What's the right tools for my operation and how do I use them? Simple part. My conversations in the last 10 years have shifted as I talk to growers across the nation and across the world. Those conversations have shifted from what is it to which ones are the right tools and how do I employ them best? So as a whole, our industry has gotten more aware of problems, are still looking for the right ways to identify them timely. And, as soon as they know they have them, they know the solutions are out there. They just need a little help in choosing, making sure they get the right one and it's employed correctly. So sorry, I can't give a hard number.
Nope, that's okay.
40% away across I don't know those numbers.
I don't think anybody does. It's such a hard thing to identify what rates of adoption are at.
Yeah. And then come back to your second half of your question. What's the most exciting one? Again, I'm sorry, I have to knuckle out on this one as well, because the most exciting thing to any one farmer is going to be the problem that's costing them the most. Solving that problem means the most to them. For some, that may be a low sidewall tire on their tractor or the combine, right? If you can solve that problem, that's the greatest thing. What we want to do is work with our regional sales managers who are working with our dealers and our resellers who have that one-on-one relationship with our customers, because they then are that trusted advisor that knows, hey, Bob, your biggest problem right now is not the planting process. It's the people in your operation all going a bunch of different directions. Is there a tool I can help you with? Sometimes that's the answer. It's education. It's communication. So we want to try and make sure that we're focusing first on solving that farmer's problem most often that comes with visibility of the problem. Shine a flashlight on what's occurring so we know what to solve. We get to focus very narrowly on the agronomic and the control and the operation portion of different implements and activities across the field. That's where our bread and butter is, but that's coming from that heart of, we want to identify what's costing those farmers, yield, grain, and solve that for them, because that's what they want.
Yeah. So I guess still in that same vein of like, how y'all are kind of preparing and being excited about some of these things and really staying focused on what your customers' problems are. You also probably have to be looking at what potential solutions are to problems that maybe people, are maybe 2 orders away from solving. And so if we think about some of these systems that are coming out, maybe we're thinking about robotic planting, and you've talked about automation and fully closed loop control on some of these planting operations. How exactly is precision planting kind of preparing for these next steps in advancement of technology, preparing the data structures and preparing the equipment to be able to integrate with some of these futuristic technologies that are starting to make their way to the farm gate?
So in general, we're not targeting to remove the human from and I guess I interpret your question to mean what's our role when planters are all robotically controlled?
Well, yeah, or at least when you've got like swarms, if you got one operator and maybe you've got 2 other tractors in the field that are kind of following it around, something like that too.
So one, if I just back and forth on this and we keep it light, one, we're probably a little ways from the swarm concept, but again, those swarms have to have a technology that is going to do the same thing. It's going to overcome the soil conditions as they are, pick up an individual seed, deliver it into the soil where it needs to be, and then remove all trace that we've been there so that the seed sprouts, right? Those are on the planting window, on the planting process. Those are right in our wheelhouse. So whether it's a 120-foot bar or a swarm of little individual items, that's where our heart is, because we very much believe that the yield you get, the stage is set for that when they first come out of the ground, when they're first spiking out as uniform and as close as we can get those to all happening simultaneously. That sets the stage for our perfect yield down the way. So, as we look across that, whether it's a little go-kart or a 120 bar, I'm good either way, because we're about making that process and that activity as successful as possible.
Yeah, it's fun to think about those futuristic things, but yeah, the fundamentals of
Stay
all those
the
good
same.
things, they get to stay the
Yeah.
same. Yeah. So where can people go to learn more about what precision planting is offering? Maybe talk about where they can go to learn more information, but also maybe your podcast. Can you talk about that a little bit?
Absolutely. Thank you for the cue up on that. Well, first and foremost, and probably the best recommendation is there's a local regionally placed next to our listeners. There's a precision planting dealer. There's got to be one close to you. We're pretty widespread. That's going to give the best experience, right? They're going to know your neck of the woods. They're going to know your challenges unique from someone else. We are never pushing anyone away, but we do understand that the best is our team of dealers that are out there, because every one of them, I believe, does have the customer's best interests at heart, and they're here because they have the same mission as us, and that's our grower success. So we want to make sure that they're learning and growing with us, and that's where I'd start. Outside of that, we do have a lot of outreach things. So we'll partner with our dealers and do field demonstrations and local farm shows of that nature, sales experiences. We have a Precision Technology Institute in Pontiac, Illinois, and that's very close to us, where we have a little playground. We have equipment running. You can come in, climb up in the cab, operate it yourself, kind of like a test drive on. It's not your Ford F-150 test drive. It's the $500,000 of equipment going across
right.
at 13 miles an hour. But yeah, it's fun. Those are some ways. We do have our winter conference, which is our annual event where we get to put the engineers on the stage and let them share what they've learned over the last year and make them a little uncomfortable, maybe. You always have you have us on the podcast, which is Smarter Every Season, and that's available at Stitcher, Apple Podcasts, anywhere you normally see.
Very cool.
Awesome.
So to kind of wrap up this little segment of our interview here and what's been a really cool conversation I've learned a lot from, what's one piece of advice that you would offer to our listeners who are wanting to maybe solve that problem that they have in their operation and have been wanting to solve for a while, or just be more precise in their planting overall?
Information. So whether that's adding a monitor, adding a sensor, or probably best yet, starting a relationship with a trusted advisor who can help you along that process, getting and learning more, because the more we learn and the more we can help each other grow on or learn or overcome problems, the better. And that may not have an individual agronomic value. That's definitely going to have a solid intrinsic value to their operation. So I'd say first and foremost, it's the G.I. Joe. Knowing is half the battle.
There you go.
Yep.
Awesome.
I think I can end on a G.I. Joe reference now.
Absolutely. Never thought you'd do that one before, I'm sure. Thank you to Paul Harms from Precision Planting for joining us today on the FarmBits podcast. I personally thought that was a really, really fun interview. I liked how we kind of mixed up the engineering side and a lot of the really technical aspects of what they do with some of the bigger picture aspects of what Precision Planting's mission is and how they're going about achieving that. And kind of along that line, I think my favorite part of the episode was when Paul talked about kind of the three different levels of control that they give folks in terms of their furrow force, right? Where you can actually have something that you go out and adjust manually to create the right setting. You can actually do the setting within the cab manually. You're getting sensor feedback, but you still have to set it manually, or you can have it just be fully automated where the monitor actually will set the correct set point in accordance with the sensors and just make sure that the system is maintaining what it should be. And all that is kind of embodied in this whole sense that they have of really like trying to make sure that everything is rooted in agronomic value at first, right? So like every single one of their products has to bring agronomic value to the table. But at the end of the day, they're also enabling additional value propositions, right? And however far that farmer wants to go, if they don't want to have to get out of the tractor to go fix whatever's going on back there, there's a next step, right? And so multi-layers of value.
Yeah, it's not just collecting all the data, they are using it. And if the farmer's not ready for that step, they can be very customizable. And so, yeah, that exactly like what you said leads into what I thought what my favorite part was, which was that it is so customizable. We asked about where adoption was going, and he was like, well, it really depends on what an individual farmer needs. It's so different based upon what region you're in, what your soil types are, what your challenges are on your farm. And so it's not about making a product that fits across the entire United States. It's fixing a product for a farmer. And I just think that is such a cool mentality.
Absolutely. Yeah, it's really cool.
Yeah. So with that, thank you so much for joining us today on the FarmBits podcast. Hope you enjoyed learning more about precision planting, and we look forward to having you again next week. Thank you for taking the time to join us today on the FarmBits podcast. If you enjoyed this episode, please subscribe to the podcast on Spotify, Apple Podcasts, YouTube, or wherever you listen to podcasts to be informed about the latest content each week.
We welcome your feedback. So if you have comments or questions for us, please reach out to us over email, on Twitter, or in the reviews section of your favorite podcast platform. Our contact information can be found in the show notes. We'd like to thank Nebraska Extension for their support of this podcast and their commitment to providing high-quality informational material to members of the agricultural community in Nebraska and beyond. The opinions expressed by the hosts and guests on this podcast are solely their own and do not reflect reviews of Nebraska Extension or the University of Nebraska-Lincoln. We look forward to you joining us next week for another episode of FarmBits.